Hello, my name is Robert Chappell, and today I'm going to give you a presentation called Here Comes the Story of the Hurricane. Essentially, it's building the hurricane dashboard in Tableau. And the first question is, let's get some data. And we're going to get that data can come from, in this case, the National Hurricane Center at NOAA, which is the National Oceanic and Atmospheric Administration. And they've got the HURDAT2 dataset, which is the Atlantic Hurricane Database. It lists every known hurricane from 1851 up to 2016, and it has something in the region of 48,000 lines of data. And there is quite a lot of it, and we're going today to put it together to make this version here where you see every single one tracked out, and then along the bottom a plot of the sustained wind speeds and a few other little bits and pieces that we're going down the side. And you can go from watching all of them at once, which is a little informative, down to individual storms. This is, for example, is the year 1966, so the year that the Beatles released Revolver, Dylan released Blonde on Blonde, and the Pet Sounds was released by the Beach Boys. These are the 11 storms that happened in the Atlantic Basin that year. I suppose the first thing we're going to do is look at the data. So if you go to the NOAA site and you open up their data, you see that it comes in this format. So we have along here, this is AL011851, and that says that it's in the Atlantic Basin. It's the first storm of the year 1851. In this case, it's unnamed, and then it states that the next 14 lines of data are all about it. Within that, we've got, this is the year, the month, the day, the time, and then we have the latitude and longitude as degrees north and west. And the other one that we're going to be looking at here is this column, which is the maximum sustained wind speeds. Now, to get from this data set, which is wonderful in its own right, down to something that we can use in Tableau takes a bit of work. So there's a bit of processing, for example, taking those header lines and turning them into column data, and then cleaning it up. My preference is to have years, months, and days broken out into separate columns, and you then also have to convert the latitude and longitude from being an alphanumeric down to being a digital one. And also some work is required on fixing the hours and the minutes away from the standard that they're presented in. And then you need to start adding columns that are specific to using Tableau for this particular purpose. And in this case, we have to put in a path ID, which is essentially a unique identifier per individual storms. What I've done is concatenated the year of the storm and its store number, and then you need to list the order of points that they're going to be drawn in. This is all takes a bit of time, it's very manual, and this is what you need to make this particular dashboard. And I have made this available as a download, and we can see that. Just get out of here and go to, if you go to GitHub, I have this is the address up here, the Tableau Hurricane Dashboard. I'll give a link to this at the end of the presentation, and here you can download the list of calculations that we're going to use, the hurricane data.csv file itself that I have made and altered the NOAA data. And if you want to play around with a completed hurricane dashboard package Tableau workbook, you can download that here. So if you go to the .csv file, we can download it here. And when you hit the download button, you'll be presented with the data as a CSV file. Just right click on this, and select all, and then save as, and save it to your Tableau data repository, and we can begin. We're going to collect to a text file. and we're going to go to my hurricanes one I've prepared here earlier. There's our hurricanes data.csv. We'll take a moment to look back. Here we can see the data structure. I have removed every column that isn't necessary to make this particular dashboard. So we have still here the year, the maximum sustained wind speed, also broken out the month and the day, the path ID and the order of points that I discussed earlier, our latitudes and longitudes that, as you can see, Tableau has already picked up that they are geographical indicators, the name of the storm, and again, the hours and the minutes. So with that, we can go and begin creating our first worksheet. And what we're going to do here is click on the latitude, click on the longitude, and again, these have already been examined by Tableau and considered to be geographical data, and they're processed as such. So far we're not doing particularly well. We've just got one dot on the screen. So what we're going to do is break this out by path ID. This is our one unique code per storm. Drop that onto detail, and now we have one dot per individual storm. And if we then change our marks from automatic, which is pick the dot, and change it to line, we get this rather crazy line that joins everything up. So we need to tell Tableau to join these lines together. So we're going to take our order of points, put that onto path. A little bit of processing, and we find that it's just as big a mess as it was before. And the reason is that our order of points is considered to be a measure because it's numeric data. If we turn that to being a dimension, take it off. So take off the order of points, and we put this one back on our dimension as a path. And suddenly we have all these lines. So we can do stuff like put the name onto label. We can put the path ID onto color. So everybody gets, every individual storm gets its own color. So we've seen the name coming up, and we're seeing now they're all multicolored. And we can go up here and change the sheet name to Hurricanes in the Atlantic Basin. Now, that's all well and good. It's all very nice, but we need to break this out by date. And so if we go here to create calculated field, this is going to be our date field, and we're going to use the make date function here. We're going to drop in our year, comma, month, comma, day. And we're then going to take that date, we're going to put it onto the filter, and show it like this, range of dates. And we're going to show filter. And that's okay. You can have this double-ended calipers that you can select your dates, but that's not what I wanted. I wanted to be able to show all of the dates all at one go. So we're going to take that off. And we're going to put it on as a filter on the year of the date. Now, we're given a list like this. So instead, what we're going to do, instead of having all of them, is just change it to a single value slider. So here we can see 1851, and pop along, here's 1929. And for anything else that we're going to use, we're going to put this on using all the next thing is that all of these lines, they show exactly where the hurricane went, but they're all kind of a bit stringy and spaghetti-like. So if we take our maximum sustained wind speed and put it onto size, we suddenly see parts of these lines thickening and thinning depending on the size of the storm at any particular time. Now, we can go back up here and we're going to change the title because we want it to be interactive. So because we've used our year of date here, we can now select it here. And we're going to put it in bold. So it's now saying hurricanes in the Atlantic Basin, 1979. But if we change our slider to 2005, the heading is now interactive and it brings up 2005. So now we're going to go on and create a timeline. And the first thing we're going to do is create a calculated field of date and time. And to do that, we're going to use the makeDateTime function, and it takes in the date followed by the time. So we already have created the date up here, so we can just drop it in. And then to create the time functionality, we use the makeTime, and we drop in, it takes in the hours, it takes the minutes, and because we don't need or want individual seconds, and we don't have them, we're putting in seconds just as one. So here we have date time. We're going to put that to columns, and we're going to change it from year as it's showing here down to exact date. And we're then going to take our maximum sustained wind speeds, drop it onto rows. So we have this rather jagged look at the wind speeds in knots plotted against the time. In this case it's over the year 2002, and that isn't really what we need, so we're going to drop path ID down to detail to break them out into individual ones. We can also drop path ID to color them all individually, and it's a bit of a cheat, but if you then want to make it a little bit more distinct, showing that the higher values are connected with stronger winds, we can drop our maximum sustained winds onto size, and so we end up with this this graph that shows the timeline where individual storms overlap each other or don't overlap each other on the timescale chosen. So we're going to edit that to edit the axis, move date and time, and we're going to just hide that header. We can drop the name onto label, and so this is our, we call it max sustained, if I can spell it, so this is our maximum sustained wind speeds over time. And that's our second major graph. So we're going to do a few of the smaller ones that run along the edge that are just numbers. And this one is going to be, I'm actually just going to take these from my list of calculations. These are the number of storms. So we again create a new calculated field. So this is number of storms, and we're just using a very simple count distinct of the path ID, and that'll give us our number of storms. So pop it on here, 14 storms, and our next one is going to be our calculation for the maximum wind speed. So another new calculated field, maximum wind speed. So again, we're just taking the max value of the maximum sustained wind speed in knots for our data selected. We're going to, our next one then is our mean wind speed. And I think I just want to include this one because rather than doing everything out again from the top, we can just take maximum wind speed, we can duplicate it, and then we're going to take the copy, we're going to rename it as mean wind speed. I'm going to edit it. So instead of giving the max, it gives the AVG value, the average, and don't forget, if you're going to include a comment, to make sure the comment is correct. So there's our mean wind speeds. And the final one is a little bit more complicated. It's going to be looking at our average duration. So again, a new calculated field. Take that out and use it as our title. And what this does is it uses the fixed level of detail expression on the path ID to find the maximum date and time. It does exactly the same using the fixed LOD to look at the minimum date and time. It takes the difference between them and then averages it. It looks more complicated than it actually is. And there's our average duration. So with all that, we now have enough to actually go build our dashboard. I prefer to use as large a size as I can get. So we can drop on our sheet 1 here. This is our map. Underneath it, we have our maximum sustained wind speeds. We can drop that down in size ever so slightly. We don't need path ID. I gotta say, pretend that we don't need that one either. And so we can then bring these in and drop them here. This is our okay, we're just going to break here, and this is our number of storms. This is max wind speed. This is our mean wind speed, and finally this is our average if I could spell it in calculated in days. So we go back here to our dashboard, and so we now have our number of storms, our max wind speed, our minimum wind speed, and our average duration. And just go to these and say fit by width. We can then start, once we can get to see them, we can then start formatting here. So we have our pane, bring that up in size, center it, and you can do that with all of these. And then you can change one variable up here on our year of date, and you can see that both sets of graphs change with that, and our number of storms and our max wind speed and all these other calculations reflect in the same way. So with that, I want to go back to the PowerPoint and ask you a question. Can you spot the error in all this data? And I think it's safe to say that you probably can't. If I bring it down just to 3 lines, some of you, if you study it a bit, you might notice that there is an error in just one little part of those 3 lines. How about now? Can you see the error now? And what I'm looking at here in particular is this giant zigzag in Hurricane Carla in 1956. And what happened here, according to the data, is that in 6 hours it went from here, it travelled to the west 1,100 kilometres, and 6 hours later it travelled back another 1,000 kilometres. That doesn't seem particularly likely. And to do that, it would have had to been travelling up to 185 kilometres per hour forward velocity. And considering that the expected forward speeds of a hurricane at this latitude would be something about a third of that. This seems a little bit unlikely. And my point here is that it's very hard to pick up this kind of error within the data itself, but it's stunningly obvious when you start looking at the individual parts of a visualization like that. And why did this happen? Well, it happened because somebody put in a W for degrees west of the Greenwich meridian rather than east. Considering that most of the data is to the west of the Greenwich meridian, it's not really surprising that they'd make this one little error. However, again, it's sat in that data for many, many years and it's not been noticed. And I wrote to NOAA and got a lovely letter or email back from them saying, thank you very much, but we've got Storm Harvey to deal with at the moment. But when they got back to me, they admitted, yes, that it was an incorrect part of their data set, and it's now being corrected. My point here is that visualizing your data allows you much greater insights into some of its aspects. In conclusion, I'd like to say that in general, data visualization rocks. I really hope that you've enjoyed watching this particular one on the Hurricane database. And in general, Tableau is magnificent. And with that, I'm going to say that you can get the original data from the NOAA site here. That sample data, there's a package workbook as well on GitHub that can be found here. I have a page on Tableau Public, which can be found here. And I also blog about data at Demon Core Data, and you can find that here. And so with that, I'm going to say thank you very, very much for listening. Goodbye.